Welcome to this course on mathematical foundations of computer science. As the name suggests, as part of this course we are going to focus on mathematical tools, techniques which are necessary to learn subjects, concepts in computer science. Computer science as such, we are concerned with solving problems The science in computer science talks about or investigates what can be computed and what cannot be computed, or what problems can be solved, what problems cannot be solved. So to talk about science and computer science, so we need sophisticated mathematical tools, techniques, and to investigate this field further. As part of this foundation course, we shall be focusing on discrete structures, automata theory, linear algebra, and probability theory. So what is so special about mathematics in computer science? Mathematics gives you abstraction. Mathematics gives you modeling. It talks about something called precision, consistency, and the statements can be expressed in an unambiguous way. So the computer science is all about solving problems, and when you talk about problems and its solutions, the first thing is how do you represent the problem? How do you represent them mathematically? How do you represent the problem precisely, which is free from ambiguity and so on? And the study of these, or the focus of this course, is to ensure that you are trained on these aspects. And now that it is formally written, and next task is you want to get to the solution track. So the first task is modeling. So what mathematical models should I use to solve these problems? Or can I reformulate this problem so that solution to this problem can be obtained easily or through some already known solution? Or you solve the current problem using solution to some known problem. So things like this. You model the problem of interest into a form so that you can get to a solution efficiently or in quick time. So things like that we shall focus as part of this course. If you look at these concepts, why should we learn? And why should I learn these techniques, tools, and so on? The computer science stream as such, if you look at it, majorly it has got a theory track, then something called system track, then applied or application areas. So as part of theory track, we study subjects like discrete mathematics, data structures and algorithms, design and analysis of algorithms, automata theory, and so on. System track, we study operating system, computer networks, compiler design, and so on. And Applied and application areas, we talk about data mining, image processing, pattern recognition, all that. And we also study computer architecture as part of system track. So to study these subjects, or broadly these tracks in computer science and engineering, we require some amount of mathematical maturity. Reason to understand the concepts, the problems that are that you come across in so and so domain, to formulate the problem, to model the problem, and to get to the solution, some amount of mathematical maturity is required. So the focus of this course is to train you on such mathematical tools, techniques, so that when you start doing fundamental courses like this, or advanced courses on these topics like advanced operating systems or advanced computer networks and computer vision, bioinformatics, things like that. So the first part of the course, we shall be talking about discrete structures and automata theory, using which you can talk about the formal representation of a problem, something called first order logic. And then we talk about proof techniques, and we teach you some basic techniques and tricks using which a given claim can be proved. Then we get into mathematical models as part of the module automata theory. We talk about various mathematical models and how are these models useful in modeling the problem, and subsequently it will put you at ease when you talk about solutions to the problem. Then we talk about linear algebra and probability theory, which play a crucial role when you start learning courses on operating systems, computer networks, data mining, machine learning, computer vision, pattern recognition, and so on. So the objective of this course is to expose you to necessary mathematical tools and techniques which will be of use when you start doing courses from each of this track. And as part of this course, when we teach you a technique, we will also tell you some application where it is applied and all that. We will also have a couple of assignments, hands-on problem sessions, tutorials, which will train you further on tools and techniques which are discussed as part of this lecture series. And you are also expected to refer standard text and then ponder on a couple of exercise questions, some application oriented questions which are applying these tools and techniques. So to start with, we shall look at discrete structures, and maybe 10 to 15 lectures we will focus on discrete structures. We will talk about various discrete structures that we come across in computer science and application for each of them, which subject in computer science uses so and so structure, all that we shall highlight. Once you are exposed to formal representation of the problem, which is precise, free from ambiguity, and it is consistent, then we introduce you to mathematical models that will slowly take you to the solution approach or solution track. Then we get into linear algebra. We talk about vectors, vector spaces, matrices. We will introduce you to a couple of sophisticated theorems and tools which will be of use when you start studying machine learning, computer vision, pattern recognition, and so on. And the field probability theory will help you to model problems using random variables. It will expose you to probability distributions and what distributions are used to model, say, in delay tolerant networks or in the study of reliable computer networks. So such introductory material will also be covered as part of this course. And let's begin with discrete structures.